Everyone, this is the next video for session W24 of FSCI on working with scholarly literature in R. The focus of this lesson is going to be rcrossref and using the rcrossref package in R to query the crossref API and pull that data into an R session and work with it within R. What are some of the various functions and parameters we can add to our query to get data back, and what sorts of data come back, what formats is it in, what are some ways that we can save that data, and then finally, what are some ways that we can use a set of DOIs to query the Unpaywall API, which is in a package called ROA DOI, and that will allow us to get information on open access availability for the articles that we issue queries on. So I'm going to go ahead and share my screen. And just as with the other videos, there are multiple ways to access the notebooks that we're going to be using for this session. The first is, close this. The first is on the course OSF page, where we'll go into day 2. And we will click on read more. And we will launch the binder here. The other way to access it is on this website. If you go down to the rcrossref lesson, you can launch the binder right here. While that's building, let's talk for a moment about what Crossref is. Crossref is a nonprofit membership-based organization that their intent is to make research outputs easy to find, cite, link, and assess. So publishers will submit metadata for their published research to Crossref. When I say metadata, I'm talking about general metadata that we would get on an article or a book, where it's not just articles, it's any type of scholarly output. So the title, the authors, the journal, the issue, the volume, the page numbers, the DOI, the ISSN, or the ISBN. But it includes a lot more. So it may include information about the authors, like their affiliation or their ORCID ID. It may include the references from that article. In other words, it could be this is not a required field for publishers to submit, but they can submit for each article that they publish, they can submit a list of references, and that would then allow you to explore the references and do bibliometric analysis. And the Initiative for Open Citations has partnered with Crossref to make that citation data available in the Open Citations corpus. So, and there's a R package for that as well called Citecorp. We're not going to be going into that during this session, but that's out there, and that's going to likely to revolutionize the way that we do citation analysis as it continues to grow. So it includes that data. It may also include funder data. So if the article is funded by the NIH or the NSF, that data is included. And so it's a range of metadata. And the purpose of this tutorial is to help you get that metadata and pull it into R. And so we do that through their API, which they have made open. And if I jump over here, there are some important links here. There is the Crossref REST API documentation. So if you're going forward, this is kind of must-read material, documenting in detail what's involved with the API and how to use it. There's also the documentation for rcrossref, and some other helpful information here. So when I say API, that is what I mean. An illustration of an API you actually use all the time. When you open up a web browser and put in a URL, your browser then sends a request to the server where that website is stored. And that server sends back a response, and that response is an HTML and CSS web page that your browser then decodes and shows you the display. So that's basically what we're doing. And some organizations have APIs that they make available for others to develop applications on. So you might be on a website and it could have Amazon pricing data. So they might be working with the Amazon API to display live in some kind of a widget, a product and current price information. Or you might use a website API to schedule a meeting in Google Calendar. So it's connected to this, in this case, these are third-party APIs that they're using to allow you to make that request in Google and schedule an appointment without leaving their website. So APIs are all over the web, and really they're just ways to get different systems to talk to each other, to exchange data. And that's really what we're doing here, is we're going to be formatting queries to send requests to the Crossref API. They're going to receive those requests and send us a response back, which is going to be typically a JSON data data sort of structure. I talked about JSON a little bit in the lists video, which was optional, but effectively JSON is a format for nested lists, and we'll be talking about that throughout the session today. So, and then what rcrossref is it's a package that was developed by Scott Chamberlain, Haoju, Nico Jan, Carl Bediger, Kartik Ram, as part of the rOpenSci set of packages. rOpenSci is an amazing organization that develops software to support and facilitate open data, open science, and open source software. They are also a nonprofit organization, and as you can see, it was founded in 2011, and they have created a ton of packages for use in R. If you click on the packages link, I'm going to limit it here by literature, but you can see there's a range of tools that they've developed, including a client to access the Crossref API, to search the PLOS, Public Library of Science journals, to access full text of scholarly articles, to access and read data from JSTOR directly, or PubMed, or ORCID, which we'll be doing next time. And ROA DOI is also part of the rOpenSci suite of packages. And this is, as I mentioned earlier, to find free open access versions of scholarly publications. So really this whole session is made possible by the work that these our OpenSci has put into developing and making these packages freely and openly available. So when we're using rcrossref, that serves as sort of a wrapper to the Crossref API to allow us to make these requests in R and pull the data into an R session. And so you don't have to use rcrossref to make requests of the Crossref API. It's only one option. There are other ways of accessing APIs. But this is convenient because oftentimes the data that you pull in needs some reshaping and wrangling, and so you can do that within R. And it's also nice because of the development work that R OpenSci put in that really makes it much more clear, shaping your query, and it allows you to be much more precise. So a huge acknowledgements to both Crossref and R OpenSci and Scott Chamberlain for their development work on this. All right, so let's see if our notebook has launched, and it has. So the first thing that we're going to do is load our packages as we've done in previous sessions. rcrossref and roadoi I've just described. dplyr is a package for data manipulation. Per is a package for working with lists, which is how the JSON data is pulled into R. There's a whole video about working with lists in R where I go into much more detail on that. String-R is a package for working with character strings in R, and then tidyr is a package for kind of reshaping and restructuring data. So we'll be making use of functions from all of these libraries during this session. And then this is just a way to get the data that we're printing out here to fit and in a way that we can look at it in a much more neat way. So, alrighty. The first thing that we need to do is to set our email address to be issued with our queries with Crossref. So you don't actually have to do this in order to use the Crossref API. Crossref the API is open, but as they state here, they encourage users to send requests with their email address, and they will forward those requests to a dedicated API cluster to improve performance. So, and it's just considered general good practice to send your identifying information. And that way too, if there are any issues, they'll be able to get in touch with you and contact you. So I'm going to replace this with my email address. Run that line. And so this sys.setEnv, that's setting this Crossref email, setting that into my R environment, and that's going to be implicitly sent with my requests through Crossref. And that's the way that rcrossref was written. I'm gonna actually turn my video off here. All right. The first thing that we're going to do here is to get publications from journals using the CR journals function. So what CR journals does is take an ISSN, which is a standardized number that journals use, a unique number that refers to that specific journal. And sometimes journals will have both a print ISSN and an eISSN. You can get a full list of publications on the Crossref website. If you are interested in that, there's a long browsable list of titles that you can download. As I stated earlier, Crossref is entirely dependent on publishers to supply the metadata. Some fields are required while others are optional. So you might be interested in what metadata publishers have submitted to Crossref for a given journal. For example, does this publisher send ORCID IDs of their authors? And what percentage of articles have ORCID IDs? Or what percent does this publisher send references that I can then take for each individual article? Are the full text of articles deposited with Crossref? Those kinds of things. And so the way to get that is to do the following. First, we're going to assign we're going to use PLOS, Public Library of Science, +1. That's a journal publication. So we're going to use that as our example. And the first thing that we're going to do is set the +1 ISSN to this variable. And what that does is that's just a character vector that is stored in R's memory. So you can see if we print it out, it just prints out that number. But we're going to pass that ISSN to the CR journals function. So we call CR journals, and then we set the +1 ISSN as the argument to ISSN. In other words, that's what's called passing an argument. So we're passing that ISSN to this argument. And the other argument that we are passing is we're setting works to false. And what that does is then it will go retrieve the data that the journal, about the journal, and it will not retrieve works from the journal or articles. So I'm going to run this, and I'm going to show you something here that we're going to have to deal with throughout the entirety of this session. And that is we're actually getting back a list of 3 items. So the first item is meta, and that's null. The second item is a data frame, and that's good. That's what we want. And then the third item is facets, which are also null. So I'm not going to talk about these first 2, but I'm just going to show you what we do to just get the data back. We don't want this, we don't want meta, we don't want facets, we just want data. And the way that we do that is by using the pluck function from the per package. And as I talk about in the previous video, pluck is a way of kind of indexing into lists and retrieving information out of those. And so what we're going to do here is we're going to do the same exact function as we did just now. So we're going to run it again. But this time we're going to add another step to it. And we do that using the pipe operator. As I've discussed in previous videos, what pipe does is it takes the output from the previous function and it uses it as the input to the next function. So the output to this function is these 3 list items, okay? And anytime you see this pipe operator, think in your mind that this, the word then. So I'm going to take these 3 items, then I'm going to pluck just the item called data. And then before I run that, I'm going to go ahead and print that out to the console. Okay, so it issued the same exact call as before, the same request, and we got back the same content, but I took the extra step to say, just give me, assign to this variable the data set. That's all I want there. So the other 2 items are basically gone, which is fine. And we're going to talk about what all of this is here in a second. So this is precisely the same thing. Like I didn't have to assign the ISSN to the +1 ISSN variable. That was optional. I also did not have to write out ISSN equals. But I do that to make things crystal clear, and so that I can just look at this function and I know what ISSN is in there, and I know for sure that I'm passing it to the ISSN argument. So I'm not going to run this because I would get exactly the same thing. All right, so we can print it out here again. And there are a number of ways to explore this little data frame. We can see it's just one row, but it's got 53 columns. And we can look at that if we use stir, which kind of compactly displays information about a data frame. And we see then we have one observation of 53 variables. And whenever you see this current, Crossref maintains a current file of more recent submissions and a back file of older archived submissions. So, and then some of these variables are true false. So first of all, we have basic information about the publication, the title, the publisher, the ISSN, the last time the status was checked, which was today. And then some logical variables. Remember, logical is true, false in R. So these ask questions like, are the abstracts on file in the current file current? No. Are the ORCIDs in the current file current? Yes. Are the affiliations in the back file current? No. All right, so I'll let you all look through some of this, but there's really good information there about what data Crossref has on file for each publisher. For instance, does the publisher keep licensing information for each article on file for the back file and for the current? And then we get down to some percentages in decimal form. So what percentage of articles in the back file have at least one license attached to them? 99%. What percentage of articles in the current file have at least one funder included? And 60%, which is a really strong number. What percentage of articles in the current file have at least one author with a current ORCID ID? 92%. That's really good. You can actually visualize some of this on the ORCID participation reports at crossref.org/members/prep. So if I put in Public Library of Science, note that this is for the entire set of journals archived by Public Library of Science, not just PLOS One, which is just one of their journals. But here you can see that 100% of their articles are submitted with open references. 92% of their articles have ORCID IDs. 52% of their articles have funding award numbers. So that's really strong numbers there. All right, you can also do the same kinds of functions that you use to explore any data frames in R. What are the dimensions, or how many rows, or how many columns are there? Or this one's helpful, what are the column names? And if you really quickly need to look through those. All right, so as we've discussed previously, you can use the $ symbol to work with particular variables. So for example, if we wanted to look at the publisher column, we could put in our data frame name, $, and publisher. And if we actually wanted to return that to a variable in itself, we could do that as well. I'm not going to do that because I don't really need it. So we can see when we just print that out to the console, it prints Something handy is what's called auto tab complete. So when I start typing, if I press the tab key, it will give me an option for objects in my current R environment that match that character string. So +1 details is what I want. Then if I press the $, and then if I press the tab key again, I can scan through the list of columns. And especially for a data frame that has as many columns as this, that's quite helpful. All right, so other things we can do is print the total number of DOIs that it has on file, 237,188. And so note that this data is, even though we called the information for this particular journal, this data applies to the publisher, not just that particular journal, right? And are the funders current? Yes. What percentage of articles in the current file contain at least one funding number, award number? The funding award number is the number assigned by the funding organization in order to identify the specific piece of funding, like the award or the grant. So 51%, which is pretty much what we saw right here. Okay, so now it is a try it yourself exercise. And actually, I meant to clear this out. So if you want to try this out, you can practice, pause the video, and decide if you just want to look up any journal that's in Crossref, or if you want to just use one of the ones that I have as an example here. So I'm going to use this one as an example, Library High Tech. And I'm going to grab the ISSN. And I'm going to say high tech. I'm going to put that ISSN in there. Notice that I use single quotes. You can use single or double quotes. Now look up the journal details using the CR journals function and assign it to a new value. So I'll say high tech details, CR journals, ISSN equals high tech, equal false, and I'm going to pipe in, and I'm going to press tab just because it makes it look neater. Pluck, get the data, and we will print info by typing the name. Here we go. And how many total DOIs does it have on file? DOIs, 1890. What percentage of articles in the current file have ORCID IDs? So coming back up here, that's going to be ORCID's current. Here we go, ORCID's current. That's what we want. So 0.33, we can multiply that by 100 if we want an actual percent. Does this journal provide open references in its current file? So here we want to go up to this logical set of variables, and we want to look for deposits, open references, current. Yes, it does. All right, so that's that exercise. Now, to get metadata for the publications themselves, rather than just data about the journal, we're still going to use the same function, CR journals, but now we're going to set works to true. So you can see here, we're passing the +1 ISSN, we're setting works to true, and we're adding another argument here, and that is limit. That will give us back a limit of 25 articles. The default number of articles returned is 20. The max limit is 1,000, but you can get more using the cursor argument, which I'll briefly review in a moment. So I'm going to go ahead and send this API call, and you can see, don't worry about this message. It's just has to do with a change that was made to the dplyr package. So you can ignore that. There was an asterisk here. I mean, that was pretty fast, right? That got metadata for 25 articles in just a few seconds. So now if we print these dimensions, how many rows do you think we should have? We should have 25 rows because our limit was 25. And we're going to have 28 different columns. So we can call names to see what some of those columns are. Now it's a completely different set of columns than when works was set to false, because now we actually have some article metadata. Now I'm going to show you something that I mean, you can do it if you want to, but if I just print +1 publications to my console here, it's going to take a while, and you'll see this asterisk running, and then it's going to look kind of weird. And the reason for that is, if it renders here, and it might not even run, here we go, okay. So the reason for that is that for some articles, I'm scrolling down right now, like this one, when it does provide author data or references, they take up all this space. And that is because references are a nested list, and I'll talk about that in much more detail to come. So if you want to compactly just quickly look at your +1 publications, I'm going to delete this here by clicking in the margin and pressing the D key twice. Yeah, because there are nested lists in the data, we're going to use the select function from dplyr, and we're only going to choose certain rows to display. And this is a much more easy to browse. And you'll see that each one of these columns is what I selected here in the order I selected it in. So that's what I'm going to recommend you do if you're in this Jupyter Notebook environment. You can also pass multiple ISSNs to CR journals. So we can take the ISSN for the Journal of the American Medical Association and the Journal of American History. We can pass each one of these into their own vector. And then in order to run our query, we use C to combine them. And here I set the limit to 10. So what this is going to do is it's going to go to the API, and it's going to retrieve the 10 most recently entered or modified articles from Journal of American Medical Association, then the 10 from the Journal of American History. In other words, we're passing just this vector, a character vector of length 2 to ISSN, and the function knows, okay, first get this data, then get this data. And we're going to have the same names as we saw before. Actually, there might be some different names. It looks like there is. Yeah, so this one has clinical trial number because +1 publishes articles associated with medicine and health. So, but here, obviously, JAMA does as well, but the articles that we returned don't have a clinical trial number. So you're not going to get exactly the same set of variables back from every single API call that you make. But I'm again going to print that here real quick just so we can look at it after I have selected only certain variables. And we can see these first 10, Journal of the American Medical Association. And then as we scroll down, we have Journal of American History. All right. So both of those are great ways of just getting a set of publications from a journal. But if we want to be more precise about what publications we're getting, then we need to use the filter argument. Okay, this is a different filter than the one we learned about in the video on data exploration. That filter was part of the dplyr package, and it was a way of subsetting data after from a data frame. This filter is actually an argument within CR journals, and it's a way that we could specify parameters as the query is executing. And another way of saying that is sending parameters along with our API request that dictate what data comes back. So this is a list of available filters, and you can see it's really quite robust. When it was published, whether or not it has a license, whether or not it has full text or references or ORCIDs, looking at specific award numbers, abstracts, and so on. This can be a really powerful way of getting and precise way of getting data back. So let's say we want to use the from pub date and until pub date. In other words, we only want articles in a given time range. So what we're going to do here is we'll work with the Journal of Librarianship and Scholarly Communication. And we'll ask for all articles from this journal published after January 1st, 2019. So first we set the ISSN, then we execute our query, and you'll notice the filter function is here, or argument. It's an argument, right? So we set the ISSN, we set works equal to true, and then we set filter. And filter, the argument has to be within a C combine, okay? Even though there's only one kind of thing in here, one argument, it still has to be inside of C. And so we say C is from pub date, and if we refer back up here, from pub date is right here. So we're just using that, but notice that we're replacing the slashes with underscores. Okay, that's the way that the filter works in this function. So I'm going to execute this whole code chunk, which is going to do all of this. And then we didn't use until date, until pub date. So we just said from pub until now. And so if we look under the issued column, we should not see any publications prior to January 1st, 2019. And it looks like that's the case. So it looks like we were successful in that. Another example of using filter is to filter by award funder. So here, let's say we want to return all publications in +1 that were funded by the NIH. The way that we're going to do that is we're first going to go to the Crossref funder registry, and we are going to download the registry CSV to get a list of all funder identifiers, which I've already done. And we're going to pass the, we're going to assign the +1 ISSN, and we're going to assign the NIH funder DOI to this value. Okay, now we are going to run our query. We're going to set the ISSN. We're going to set works equal to true. You know, I just put a T there, but it's really better practice to spell it out. But T works. It's just generally considered not good function, good style. We're going to set our limit to 25. I don't want to get more than 25 articles right now because we're doing a teaching activity. And then again, notice that we, when we set our filter argument, we surround the entire thing with a C. Our award funder is set to this NIH funder DOI, which we specified here. And our pub date, we're saying from July 1st, 2020. And then you might notice, I think I haven't been saying this every time, but pretty much every single time you're going to pipe in the command to pluck the data so that we just get the data set. And that is issuing. You can see it's working. So it should be working. Before I go here, let me just visualize it very quickly. I'm going to copy our select set of columns, and I'm going to say +1 applications NIH, and I'm going to select, and let's just take a quick look and make sure everything looks okay. And it does. So we have a number of articles here that theoretically should all have been funded by the NIH. So now I'm going to introduce something. I'm going to jump over into the course website real quick. And I'm going to show you what this looks like coming back. So we see these are the same columns. If I print names, container title, created, deposited, published online, etc. Those are the same things that we're seeing here. So each one of these, this is a query for 5 different articles from +1, right? This is a kind of glimpse at what JSON, a neat way of looking at JSON. Each individual item has 5 entries. So the journal was +1 for each one of these. These are the different created dates for each one of the articles. The deposited date, the public data was published online, the journal ISSN, the journal issue, so issue 9, issue 3, the number of references. Now, all of that's pretty straightforward, the URL to the article, until we get to these last 5. Now, these last 5 are what are called nested lists. So we're about to deal with the funder, so I'll look at that. When we unnest funder, we can see that for 4 of the articles did not have any funder information, but article 2 did have some funder information. So we unnest that. And now we see even more nested data. We see DOIs for that refer specifically to the funder. So it looks like this particular article was funded by 3 different agencies. These are the DOIs for those 3 agencies. These are the names: the Natural Science Foundation of China, Natural Science Foundation of Shandong Province, and the Fundamental Research Funds of Shandong University. The award number, and if there are other award numbers. Okay, so you can see that this is a fairly complex object here. We have 1, 2, 3, 4 levels deep before we can get to the data. Right, that's why we're not working with just two-dimensional data here, rows and columns. Another way of illustrating this is to look at the authors, where each one of the 5 articles has a set of authors. Within that, each author has a given name, a family name, and the sequence in which they appeared in the article. So that's why we have to use some extra special functions, and that's why it's nice to bring this API data into R, because we can get that data out in a nice, neat way, all in one place. So one way of doing that is to use the unnest function, which is part of the tidyr set of packages. And so what we're going to do here is unnest funder. Now, if I take the dimensions of, I might have to add a function, an argument to this real quick. Okay, I'm going to unnest, but I'm going to add the argument drop equals true. And what that is going to do is it's going to, oh, that's right. They just updated tidyr to stop using this argument. So that's okay. No big deal. We can go forward without that. If we look at the dimensions of this data here, we'll see it's 25 rows with 27 columns. Now this one we see is 58 rows and 38 columns. So what happened when we unnested funder? Well, if we scroll over to the funder section, we can see that it took all of the funder information and it unnested it. So now there's going to be, for each row, the row will be duplicated the number of times that the funder appears. Okay, so this is kind of hard to visualize, but bear with me a second. Our first article, looking for the title. Okay, our first article title is Distortion Correction of Diffusion Weighted MRI. Now, if we scroll over to the funder information here, we can see NIH, and the column is replicated. I mean, the row is replicated. So row 1, the title is distortion correction. Row 2 is also distortion correction. Row 3 is distortion correction. 4, and then it goes on to the next article. So what that means is that this article had 4 funders, and when I unnested it, it created a new column, a new row with the funder data for each one of those funders. So whereas previously all of this funder data would be nested in one place, now it's expanded. So we can see that the NIH, the Vanderbilt Institute, National Center for Research Resources, and the Department of Defense funded this article. And these are the funder DOIs. So we should see the funder DOI that for the NIH there, which is 13039 and all of those numbers. And if we scroll up, that's exactly what we saw here. And then some other information about the funder, like the award numbers. All right, so unnest is a tricky concept to get, and we'll be coming back to it when we in other places throughout the lesson. So if you didn't get it now, then you'll have an opportunity to get it later. Now, okay, there's a short assignment. We're going, or a little homework. We're going to run a CR journals query with works equal false to get information on scientometrics first. So I'm going to do, say, scientometrics. Let's just call it SC ISSN equals. And I'm going to say SC details gets CR journals ISSN equals SC ISSN works equal false. Then I'm going to call stir on SC details. Right? And the questions, does the current crossref file contain funder information? So we say deposits funders current true, so that would be yes. What percent of articles in the current file have at least one funder listed? So we could say, sorry, I'm looking for funders current. Okay, so we can say, now, no, if I execute that here, it's going to rerun this API query. So I'm going to click insert cell below, and I'm going to put that here, SC details funders current times 100. Not funders current. Sorry, I lost my train of thought there. What percent of articles in the current file have at least one funder listed? Yeah, that should be funders current. Why isn't that working? You know why that's not working? Because I did not pluck the data out of it. Sorry to subject you to that. And I should have known, because when I did a stir, this is a list of 3. There's our meta, which is null, our data, and our facets. So that's a good reminder to you that we all make mistakes. Now I have a data frame of one observation of 53 variables, and I can do funders current 100 and see that 44% of articles in the current file have at least one funder listed. And then the question, what percent of articles in the current file have at least one ORCID ID? And we could say ORCID's current, see, and get 74%. Now find out if NIH has funded any publications in the journal since 2015. So we're going to use the filter function here, and we are going to say SC details ER journal SSN equals SC ISSN works equal true, because we do want article metadata. And then we are going to say filter equals C, because we have to wrap it up. And we have to say award funder equals NIH funder. I've already assigned the NIH funder DOI up here, so I'm just going to paste that. I don't have to do that work again. CR journals. And then, of course, we want to end by plugin. And then the question is asking us to print it as select parameters. And I put by accident 2 pipe. So now it's working. We can see the asterisk working away. And here we go. And we have 3 articles that are funded by the NIH in Scientometrics, mapping the growing discipline of dissemination and implementation science and health. These all make sense that the NIH would be funding those. And then the last exercise here asks you to see if Scientometrics has any articles authored by Dr. Ann Will Harzing, who she is the developer of the software Publisher Parish, and looking her up by ORCID ID. So we're going to again do, let's say, SC Harzing at CR journal ISSN equals SC ISSN equals true, filter equals. Now, what is the ORCID argument that we need to pass? And that would be just ORCID by itself. Metadata where ORCID elements value equals ORCID. So we can say ORCID equals, here, I forgot to do something, Harzing ORCID gets, and then her ORCID. I like to, as I said earlier, set those variables outside of the API call, just so I am clear in my own mind what I'm asking for. And then we'll go ahead and make sure we plug data. And then we will print it out with these parameters so that it makes it easier to see. And here we are. She has published 4 articles, at least with that ORCID identifier in this journal. And here they are. And this is an excellent article. I highly recommend reading. I am going to skip this portion here. If you're interested, you can read it on your own. This is about finding out which articles have license information and using the filter function to get that. I'm quickly going to run through using the filter and select columns, filter and select functions with dplyr. So remember, these filter are different from this filter. So the filter in dplyr filters information after the fact, okay? So what I mean by that is we send a request to get publications from Journal of Librarianship and Scholarly Communication published after January 1st, 2019, and we get those here. But let's say after I get those, I only want to look at articles published in Volume 8, Issue 1. So that's how I would do that is if you already have a big set of data, you don't want to send another API call and get more data back. You already have the data. So then in that case, use the tools that are already available to you in R to filter the data that you already have. So in this case, we're going to filter, we're going to call the data, which we have assigned to JLSC Publications 2019. So then we're going to use our pipe to use filter and keep only those where the volume is 8 and the issue is 1. And actually, we could make things even easier, and we could just select, put our pipe our select function in and do it all at once. Why isn't that working? Let me see. I'm going to take this off and troubleshoot this real quick. Oh, the reason it's not working is because I didn't print it. So it did work, but I did not print it out to preview it. And here we go. So now we only have articles where the volume is 8 and the issue is 1. And you can filter by DOI. You can filter by detecting a certain word. This is from the string R package. So it's like saying, look in the title and just give me back any articles that have the word OER in the title. So there's a lot that you can do there. All right, there's yet another way of making your query more precise, and that is to use something called a field query. The difference between filter and field query is that field queries allow you to search in specific bibliographic fields like the author or the editor or the titles. So in other words, when you're sending your request to the API, you're saying, I only want to get back these authors or this ISBN. Or this title. Now, but keep in mind that to use field queries, you must provide an ISSN. So I can't use this to say, give me every article in Crossref database that is authored by this person. Okay, it doesn't work that way. You can't do that query, actually. So here's a couple of use cases for that. If I'm looking at the Journal of Librarianship and Scholarly Communication, and I want to get back all publications in that journal that have the word open access in the bibliographic metadata, here's how I would do it. So instead of saying filter, I use FLQ to indicate field query. Just like with filter, I wrap the whole thing in a C. And then the one kind of quirky thing is that for the field query parameter, I surround that in something called backticks. These are a key that you rarely use, or I rarely use unless I'm programming. Maybe some of you use them more often. Next to the 1 key. So if you look at the 1 on your keyboard, the backtick is there and it is shared with a tilde. So if you press shift, you get tilde. If you don't press shift, you get a backtick. So you have to surround the field query parameter with backticks. So I'm going to run this code chunk, and theoretically this should give me back a set of articles that were published in JLSC. I've set my limit to 25. That all have the word open access, like either in the title or any other bibliographic metadata fields that are searched. So here, and I'm not exactly sure which all bibliographic metadata fields are searched, but we can see just at a glance, it looks like the word open access appears in the title of all of these. So in other words, it looks like our query was successful. You can also do a field query by author. So I can do the same thing in JLSC and look up all publications authored by Dorothea Salo. And she, according to this query, has 2 publications. So this is an alternative to using the ORCID ID. All right, and we're up against a challenge. If you want to try this out, we're going to assign the ISSN CRL 2150-6701. Use the query author field to search for articles written by Lisa Hinchliffe. So let's say CRL author, CR journals, SSN equals CRL. And works equal true. Then we're going to say FLQ equals C, and then backtick query author backtick equals, and you notice here you have to separate her name with a plus And you also have to make sure and put that in quotation marks. So actually, that was a mistake there. That should be a plus. So I need to go back and fix that. All right, and then of course we always add pluck at the end, and then I'm just gonna say CRL, and I'll say select title and author. Where do we have unexpected? Oh, I forgot to put a comma after the works equals true. Oh, and it says object CRL ISSN not found. That's because I didn't run this chunk yet. All right, and here we go. All of the authors are, yeah. Okay. What did I do wrong here? So it came back with authors whose name is not Lisa Hinchliffe. So it's not I think that there's a way of specifying it more precisely, but there might not be. At least the first three are correct. The rest look like they are not correct. So be aware that sometimes that happens with your crossref queries is the results that come back with a lot of false positives. And that's just something that you'll have to work with. All right. If you want to get a first-hand look under the hood at what JSON looks like, it looks like this. Bunch of massive mess. So what this little exercise has you if you triple click inside this box and copy it, and then you go out to, like, this is going to be a huge thing. And then you go out to Code Beautify and you paste that here and you say beautify. You'll see what we saw kind of in the other window where it's a lot easier to handle, right? And you can mess with this website separately. If you want to write the JSON to a file, you can use the write JSON function from the JSON-Lite package. And this takes us to how to save files using this Jupyter notebook in Binder. Okay, I just ran this function, which means I saved the file, and I saved it in a folder called data. Now, if you want to look at it, remember all Binder sessions are temporary. So in order to, the next time, when you close this down, the next time you start it up, it's not going to be there. It's only going to be there while this Binder session is in progress. So to retrieve it, you want to go to File, Open, and that's going to open us up in the root directory for this Binder session. And remember, I saved it in the data folder, and you can find it here. Okay, so anything, and if you want to download it, you can click on the box and download it. So remember, anything that we're going over, if you want to save the data, that's how you retrieve it, and you have to do it while the Binder session is in progress. All right, just a couple more things here. We've been accessing works from the journal level, passing journal ISSNs and getting data that way. But you don't have to do that. You can also use CR works. That's a different function to get data by articles. So if I have a DOI, I can pass that DOI directly into CR works, and always plugging the data. So that's the way I get the article metadata for this particular article. You can also pass on more than one DOI. So if you have a set of DOIs or like a spreadsheet, you can read that spreadsheet into R, and you can pass that entire column of DOIs into CR works. So here what we do is we construct a separate vector that includes 7 separate DOIs. We run our CR works function when we set DOIs to my DOIs, which is this vector here, and we run this, and it will go out and it will get the metadata for each one of these. And we can see that they're all listed here, all 7 articles. All right. And yeah, if you want to read this on your own, this is more about unnesting. So when you unnest the author, what happens, and I'll let you try that out on your own. All right, so here's a try it yourself exercise. So find an article that you're interested in and create an object with that article in a DOI. So here's an example of that. Then do a search with CR Works to get it, just like we've done above. So I've done that as well. And then print the column types using map. So what that means is my article type of. So what this is doing is it's looking at all of the different column types in my article, this title, DOI, URL, and it's telling me what type each article, which column is. So we can see, obviously, this is title is a character. DOI is also a character. And most of them are going to be character. The only ones that are not are author, link, license, and reference. And that is, as like we've said earlier, these ones here that are like nested lists. So let's try unnesting one of the list columns using unnest. So we could say tidyr unnest a article. Actually, here's what I'm going to do. My article type unnest, and let's try to unnest author. See if that works. Oh, and I said set drop equal to true. All right, and what that did is it added the author data. So it added rows, whereas before it was just 1 row. Now it's 9 rows because there were 9 authors on this article. And when I look at the author data, given name, family name, and sequence, I can see sorry for the messiness here. Heather Pivovar, I hope that's how you say it. And then the next author is Jason Preem, and then there's the data about each person. So I know this looks like a complete mess, and actually if you are going to use RStudio to do this kind of stuff, you're not going to have to deal with this mess. Nested columns are actually nested. The problem is that in this viewer, it unnests a lot of the columns, and so that's why each column is like a mile long. Okay, we're approaching the end here. If you want to get more than 1,000 results, you have to use the cursor argument. I'm not going to go into that here, but there's documentation of that on the website. Right. Let's see. Right here. So you can read more if you need more than 1,000 results. There's also a field query argument to CR Works. This too, I'm not going to go into right now, but you can read about how to use that and how to troubleshoot some of the issues with that. So next, Okay, next three, there's just a few more tasks to do. First, we're going to look at how to get formatted references into a text file. So there's a function in rcrossref called crcn, and what that does is it will actually format your references according to the style that you choose. And there's a huge list of styles. If you call rcrossref get styles, you can see massive list of different style guidelines. So what this will do is it will take this set of DOIs, you pass those DOIs to crcn, you specify what format you want it in, and then you can specify the style. And then here we're plucking a little bit different. We're plucking to get the first item out of each one. So don't really worry about that last bit there. Just know that it works. And this function is getting it. And as we can see now, we asked it to put it in Chicago style, and we have beautifully formatted citations in Chicago style in 1 second. And all we had to do was put in the DOI. So that can be a huge time saver. And then if you want to save those, you can use a function called write lines. So I'm going to execute this. And remember, we can look at that by clicking File, Open, and then looking in the data folder. And we have our, what did I call it? My citations text here. And yeah, there's the formatted text citations. You can do the same if you want to format it in BibTeX or in RAS format if you want to feed those into a reference manager. Now, here's one of the most helpful and useful functions of rcrossref. So say someone gives you a Word document that has a bunch of references on it, and you want to get those references into a structured bibliographic format. So what I've done here is I have created a list of references that are just unparsed references. You can see there's just one column. It's from, I read here, what I did was I read it in. It's just a text file. And I had to specify the ISO encoding because some of the characters were, it doesn't matter, different characters encoding. And so what the goal is to then take this and then get nice, clean, formatted, structured bibliographic reference data from it. So I wrote this custom function here that does that. And what it does is, the key is you have to put each reference onto a different line in a CSV file, or a comma separated values. So like you would take your references from your Word document, you would copy those, you would paste it into Excel, say, and then save that Excel document as a CSV so that each line has a different reference on it. And then what this loop does is it goes through each line of that CSV. You can see the column name for the CSV is reference. So it goes through each my references reference column. It then runs a CR works query, and it gets back the top 5 articles that match that search. So the Crossref API assigns a score to each item returned, giving a measure of the API's confidence of the match. And then the item with the highest match is returned. So what we're doing here is we're taking the top 5, saying if it's not in the top 5, it's probably not in Crossref. Then I wrote another little custom function here that goes through and it gets the first item out of each set of returned results. So, oh, I didn't run this. So it's running that right now. Now, I would encourage you, if you really want to dig into this, to learn more about it. If you don't, then just copy and paste these functions and feel free to use them on your own. You don't have to understand how stuff works in order to make use of it. All right, so here is our, so it worked. My function says to print it as it goes along. So this is just a print out of the text file. And then if we run this and we extract the first item, we can see now we have nice and neat parsed bibliographic references. And all of these are accurate except for two. One of them, it just is completely off because the article I sent does not exist in Crossref. And then this one is actually a book review of the book that I wanted, not the book itself. So, and then I go into some more detail about how to troubleshoot that out. So if you're super interested in this, then you could read that through. Um, and then this next section talks about how to write these publications to a CSV file. It's not as straightforward as, I mean, not the publications, but like, let's say this spreadsheet. It's not as straightforward to run that as you would think because of those nested columns. So if you try and do it, in fact, it will tell you that it will throw an error. Okay, so there's three different approaches to solve that. One, and I'm just gonna, those are all listed on the website, what those approaches are under write publications to disk. So the solution that I'm going to give here is you use type of to see which columns are list columns, and then you use this function to basically force those into character. And so really don't worry about that. And it's not an ideal solution. And if you have questions about it, then just let me know. All right, the last thing that we're going to do is use roadoi to check for open access. So this interfaces with Unpaywall, which is an important tool for locating open access versions of scholarship. And there's more here on the rCrossref package, as well as the Unpaywall itself. And this incredible introduction to roadoi, which I strongly recommend you interact with because it will go into a lot more detail than I'm about to. So you do, again, need to set your email address and with the API call. And this works similar to the other tools that we've used where you take a vector of DOIs and you pass it to OA-DOI fetch. So the DOIs are, argument to DOIs is my DOIs, and the argument to email is my email. And you can see in this asterisk, it's working and it finished. Well, let's print the column names to see. We have columns like best OA location, OA locations, is OA, genre, OA status, has repository copy, journal is OA. So there's a lot of really rich data here. And we can see that for the 7 articles that we asked for, 6 out of the 7 are coming back as having an open access version. So we could use filter from the from the dplyr package to only keep the articles that are open access. And then we can use unnest to take a look at what the best OA location is. And yeah, I knew that this was an issue and I forgot to code it in. Names repair. So let me quickly take a look at the help file because I forgot how I repaired this. Names repaired, check unique. I think that's what I want to say. No, I want to say unique. Okay, so don't worry about that. But now that I've unnested the best OA location, for each article, I'll have a column letting me know what the best open access location is, and the URL to that. Um, so, and that's this information here is best, sorry, is best true, the license, and then lots of other good information there as well. All right, that takes us to the end. That was a lot of information, and I hope that you will save this video and come back to it and not expect to have done it all in one setting. And I'll talk more about it in our in-class session. But that's all for today.